And now we're going to move over to the quotient rule, which, just like the product rule, is not as straightforward. It's just saying if I want to do the derivative of a quotient of f of x over g of x, it is not going to be f prime of x over g prime of x. It's a little more involved than that. Let me write out the formula. This is going to equal g of x times f prime of x minus f of x times g prime of x all over g of x squared. Take a moment, get that copied down. Let me show you an example of using this, and then I'll show you my shortcut way of remembering this, because this is definitely a more complicated formula than just first times derivative of the second plus second times derivative of the first. Let's take a look at the function h of x equals 6x plus 1 over x squared minus 2. First of all, unlike the product rule where I can sometimes get around it by doing some simplifying, I really don't see any sort of simplifying I can do here. There's really going to be no way around this new quotient rule. Now, if I'm going to try to apply this formula, the part on the top is in the place of f of x, and the part on the bottom is in the place of g of x. I'm going to get h prime of x equals. Okay, you're going to help me out here. G of x, that's x squared minus 2, times the derivative of f of x. Okay, what's the derivative of f of x? I'm hoping you said 6. Minus f of x, 6x plus 1, times, okay, your turn again. What's the derivative of g of x? Hope you said 2x. And now this is all over g of x, x squared minus 2, squared. Take a moment, clean up the numerator, distribute, combine like terms, but leave the denominator factored, and that's how we're always going to try to leave these things. We're going to get 6x squared minus 12, minus, make sure when you're distributing the 2x, you also distribute the negative, minus 12x squared, I think, yep, minus 2x over, I'm going to leave all that stuff there, x squared minus 2 squared. And then hopefully you've combined like terms, and negative 6x squared minus 2x minus 12 over x squared minus 2 in parentheses squared. And that's our derivative of 6x plus 1 over x squared minus 2. This just gave us a formula that would tell us the slope of this function at any particular x value. Now, I feel like this formula is a little bit trickier to memorize. Obviously, all these formulas will need to be memorized. Product rule, quotient rule. My high school calculus teacher had a little trick that he taught us. Here's how this trick works. First of all, he called the top part the high part. He called the bottom part the low part. And D meant derivative. His little shortcut said low, D high, minus high, D low. Low, D high, minus high, D low. Draw a line and square below. Low, D high, minus high, D low. Draw a line and square below. Let me actually write that down, because honestly, I don't have this formula memorized. I have that little saying memorized. Low, D high, minus high d low, draw a line, and square below. And I'll make the video pause for a moment so you can get that copied down if you're watching an end puzzle. So let's try one using this little saying. Let's look at y equals t squared over 3t squared minus 2t plus 1. Y prime equals low d high. Here's low. Your turn. What's d high? What's the derivative of the top part? You said 2t minus high, t squared. Okay, your turn again. Derivative of the bottom part, d low. Low, d high minus high. D low is 6t minus 2. Now we draw the line and we square below. I'm going to make the video pause again. You take a moment and clean up that numerator, but leave the denominator as that one polynomial squared. And that's our simplified derivative. Y prime equals negative 2t squared plus 2t all over 3t squared minus 2t plus 1, that thing in parentheses, squared. Next, f of x equals x squared plus 3x minus 2 over x. F of x equals x squared plus 3x minus 2 over x. I can get around using the quotient rule on this problem. How else can I find the derivative of this thing? I'm hoping that you're realizing that just because we know some new rules, the stuff we learned about earlier still applies. I could have given you this problem back in section 2.2. I'm going to go and I'm going to separate my fraction. I'm going to say my original function is x plus 3 minus 2x to the negative 1. Then I don't have to use the quotient rule if I'm going to find the derivative. I can just get f prime of x equals 1 plus 2x to the negative 2, or 1 plus 2 over x squared. Just because we have a quotient doesn't necessarily mean we have to use quotient rule. Just like with our product rule, just because we have a product doesn't necessarily mean that we have to use product rule. If there's some algebra that we can use, we can get around that. Maybe we should do one more. One more that's a little bit messier. Let's take a look at f of x equals x over the square root of x minus 1. I'd like to see if you can go write out your low d high minus high d low, draw the line, and square below. I'm going to make the video pause. We'll deal with the simplifying together maybe. You just go use your quotient rule. Low, square root of x minus 1. D high, that's not bad, that's just times 1. Minus high, x. D low, this is going to be a little messy. 1/2 x to the negative 1/2. Draw the line and square below. We're going to get that. So I've got to clean this up. F prime of x equals, let me not in the numerator mix roots and fraction powers. Let me just be consistent and go with fraction powers. I'm going to have x to the 1/2 minus 1 minus, okay, so to multiply these things together, I have x to the first times x to the negative 1/2. When you multiply variables, you add the powers. So 1 plus negative 1/2 will give us x to the positive 1/2. I'm going to get minus 1/2 x to the 1/2. All over, might as well just leave roots in the denominator, all over that. You have some like terms that you can combine. You can combine these two to get, okay, let's see here. 1 x to the 1/2 minus 1/2 x to the 1/2. This is 2 halves minus 1/2. You're going to get 1/2 x to the 1/2 minus 1 over square root of x minus 1 squared. One tiny problem. It's not really okay for us to leave fractions inside fractions there. So I'm going to multiply the top and bottom by 2. That's going to give me f prime of x equals x to the 1/2 minus 2 over 2 root x minus 1 squared. Or, if I want to just be consistent between the numerator and denominator, square root of x minus 2 over 2 root x minus 1 in parentheses squared.